Okay, we're now recording. So welcome to the our second general meeting of the semester. So the agenda for today is, well, first we're going to start with a social activity, but then we're basically going to be doing a project review for each of the, well, we have two currently active projects and then we have one new project. So for the two active projects, we're going to be going over sort of like the planned activities for the semester in terms of what are they planning to produce at the end of the semester, and then what's their timeline and budget to get there. So each group's going to be giving a short presentation, and then there's going to be a lot of time for questions. And the purpose of those questions is so that we can spot any potential flaws in that plan so that we can try to have a more robust plan for this semester and we run into fewer issues. But first, let's start with a social activity. Oops. So this is something that we did last semester, and I think people enjoyed it. We're going to be splitting into different breakout rooms. I'm going to randomly assign those using Zoom. And then whenever you're in those rooms, you're going to pick one person to be a describer and one person to be the artist or drawer. And so then I'm going to announce a prompt. It's actually going to be a picture that I'm going to put into general and Slack. And then I'm going to start a 3-minute timer. And the describer has to describe the picture to the artist so that they can recreate it. And of course, you're not supposed to cheat and say stuff like, hey, draw R2D2 or draw a table. Like if you can give them different commands like horizontal line or rectangle or something like that to make it more difficult, it ends up being more fun, I think. So we're just going to do that for like 3 minutes. And hopefully you can get to know some other person in the club that maybe you didn't know before. Just because we have a lot of new people now, and especially since everything is online, we don't really get to interact as much with everyone else. Okay, so my screen sharing has stopped, and I'm going to pause the recording for this. Okay, so now that we're back, we can move on to the next part of the meeting, the project reviews. So these are I already went over it at the start of the meeting, and basically each project team is going to talk a little bit, and then there's going to be some time for questions. And the goal is just at the end of this, we just want to have a stronger plan for each project. A few discussion topics. You don't have to hit all of these. These are more inspiration, like a loose guide for you to figure out what to talk about. But sort of the larger aspirations for the project or what the inspiration was. The current status, specifically, what did you do last semester? What do you have planned for the end of this semester, the deliverable? What is your timeline for this semester, specifically focusing on testing? And then what's the planned budget? So, Raghava, you can take us away. I will give you sharing permissions.
Sounds good. Okay. See my screen? No, not share. Okay. So this is the robot arm project. And we'll kind of get started with kind of some inspiration, kind of introduce it as well last meeting. Our goal is really to try to kind of look deep into why a robot, like kind of the how a robot arm can be useful and how we can get a robot arm to do things that kind of humans can kind of do instead of being just static and in a confined space. And this semester, or last semester per se, we kind of were able to get the basic movement of going to a certain location and being able to kind of abstract out kind of the complexity of like a robot arm in terms of the kinematics. So usually humans, we like to operate in kind of 3D space, XYZ, and robot arms, they operate in a joint space. So we were able to map from that joint space to the like XYZ space. But our robot arm is still isn't really smart at all. It doesn't really know anything about its environment, its surroundings, and it can't really make any decisions because of that. So this semester we are planning on focusing on using the deliverable of being able to play a game of chess to add in vision as like a main way of perceiving the world, which we use vision everyday lives to do the things that we do, pick up stuff, and because of that, we're aiming on focusing on first developing the kind of or closing the loop by adding in vision, and yeah, by specifically playing a game of chess. And kind of what this kind of consists of is being able to identify the different pieces on a table and be able to localize where those pieces are, and then execute a controlled pick and place. So controlled is the key word, and using the camera to do that. So if there is error, being able to control for that using the vision system that we're planning on developing. And to kind of also display that to the world and kind of the output of what we create, we are planning on creating a demo of the game using a YouTube video, and also turning it into a ROS tutorial or a ROS DS tutorial, just because it's very kind of compact and has all the environment and everything within it and easy to distribute. So in terms of a timeline, we kind of discussed yesterday the different tasks, and this is an initial kind of layer of thinking of what kind of tasks would be involved in kind of the in hardware, being able to design a camera mount, a gripper that would be able to pick up these pieces effectively, and completing the manufacturing of the 6 degrees of freedom arm. And for the on the software side, path planning, being able, and this time, which is a little bit different from last semester, is being able to avoid obstacles, as we don't want to hit over pieces that exist on the table. So being able to plan for that and have that within a simulation environment. So focusing on that early on, getting things working within a simulation environment, and then moving to a real world environment and testing along the way, which ended up something that worked last semester. And with object detection, since that's something we're kind of looking at something new this semester, the whole vision, wanting to kind of look at each piece and kind of go a little bit more in depth with that, and kind of testing as we go with the test and repeat, being able to test and repeat after we do the different processes with that. And then in terms of position control, kind of looking at being able to just work on vision-based control with only like one piece, like looking to get it to work with one, and then moving on to more kind of complex pieces like a pawn or something that's smaller. And something that kind of decided to kind of go like further into is like test-driven development. So the reason kind of like have like the whole bar on the bottom of like unit testing is have one, like, so basically instead of spending the entire time like writing code and then testing at the end to only find you have a crap ton of errors, a lot of errors, what we do is be able to each component, like this was specifically applied for like the position control and path planning, write a little bit of code, test that, or like actually like write the tests before or like the kind of goal case of what you want to happen, and then like write the code and then test and then repeat, so that this way it's shorter kind of cycles and less like pulling out your hairs of where the actual errors are coming from. And in terms of hardware and software integration, since we do already have like a 3D printed like robot that already exists, that we've been using last semester, kind of use that with the integration testing, kind of with all the different smaller pieces as we move forward. And then at the end, when 6 degrees of freedom arm is manufactured, kind of set time to integrate with the new hardware. And then for budget, looking to just main thing is just cameras, I guess, in terms of that, and 3D printer filament, and potentially a 3D printer. This was mentioned in the Slack. Didn't really know what the status was on that. Kind of mainly for the entire club for just manufacturing in general, and then gripper parts to develop the new gripper. I don't have another question slide, so this would be a good place for questions.
I know on your previous slide, or maybe it was two previous, like you were talking about needing, like you need to distinguish between the different pieces, right?
Mm-hmm.
So are you concerned at all with how similar like all the pieces look on like a typical chess set?
Yeah, and that's why I think it's going to be like very important with like focusing a lot on like the data set generation. That's really going to like be cause, or is going to be controlling basically the entire process of like the object detection. Just due to the fact that like if we have like good quality data and like we are able to process it and put it into a state that is going to be like effective and have like enough data to do that, that's gonna be like really important. Does that kind of make sense? Or is there something
Yeah.
like that we should like look into in terms of that specific issue?
I guess I have a follow-up question too, like somewhat related, somewhat unrelated. Um, so you say that the robot arm is able to play a game of chess by moving individual pieces. So as a human interacting with the robot, what does that look like?
So usually the moves, like I guess, are independent, like there's one turn each. So a robot arm able to play a game of chess, it would be something that would be like an interactive game. So there would be another like person that would be playing against the robot arm.
So the
So
robot arm, so you're not, it's not like two people are playing and giving commands saying knight to e4. You are playing against a robot arm.
yep.
Okay.
And like in terms of like the chess engine and who's actually giving the moves, like that's something that could either be like a chess engine or it could be like a person like on like a website or something. But like want it to be kind of, I guess, flexible enough where creating that wouldn't be like the focus of what we're trying to do, because we want to mainly focus on the actual like the robot arm aspect. I guess kind of how it's, I guess the arm is being moved, like that can be that like was kind of like of smaller importance. um, do you think that's something that we should take into more consideration?
Um, I mean, I guess my sort of general feedback, um, well, I know we have another project that already sort of relates with chess. So part of me wonders if a lot of people who were interested in doing a chess project are overlapping on both projects. And if those people move to the different project, all of a sudden you're left with a bunch of people who are less interested in chess. That's one thing that I would double check on. Um,
Okay. Yeah, I think chess was mainly like, I guess, chosen just for like mainly an application. There was also like setting a table, like, and there's in terms of the actual, I guess, like the overall goal is just to build a system with vision, to be able
okay.
to accomplish a task. So it doesn't really, I guess, the task itself doesn't matter too much. It's more of just something that we thought would be cool and would be interesting. So it could be chess and it could be something else, but I guess we did like vote on it, and majority were interested in chess.
Okay, well, I think you had a really good point earlier whenever you said that the goal of the project doesn't lie in that chess engine or what is giving the robot commands. The goal of the project lies in being able to identify and manipulate chess pieces.
Exactly, because like in the future, like another reason why this I think we saw it was interesting was like it's interesting we could build off of this into something that we kind of end goal in terms of making a robot arm smart and having it learn to do things. If we had a bin full of chess pieces and wanted to have a robot learn to pick up pieces, that would be like a reinforcement learning task. What you wanted to, that was something like in the future, and that would be a very interesting application and viable. Like those objects aren't like that; they're not that big, and yet they're, I guess, small enough and kind of different enough to be an interesting like reinforcement learning problem that actually would make it like smart.
I guess my one concern, and this is sort of already just been slightly discussed about chess, is that if that's the approach you do take, you're going to be spending a lot more time on the classification of pieces as opposed to spending time on the more visual servoing aspect, which is, I think, what you're more interested in with this project. Like, I feel like there are some other potential deliverables that focus more on visual servoing efforts and sort of don't require the same amount of effort into like being able to classify and determine what piece is what.
We could modify the game so that it's easier for the robot to understand as like a first MVP, like using brightly colored dots on the ends of the chess pieces so it can track them better.
100%.
Since it doesn't have to specifically be able to pick out the nuances between a rook and a bishop. It just needs to be able to tell this piece exists in this space.
Yes.
Or something like checkers, where you still fit the game, but eliminate some of that additional need for classifying pieces.
Like April tags, and I am a big proponent of those things because they are amazing. But yeah.
So I have a suggestion about this. So if the instructions are given, so rather than talking about which piece to move, if the instructions are given in the form of move this from this location to this location, it would be simple to like overlay a scheme on the chessboard that just like labels each square. So that way you don't need to classify what a certain piece is, if that's the issue.
That's a great suggestion. I think that's something that we'll probably focus on as well. I guess with the like in the position control, that's visual servoing. Like that's kind of, I think that might be a route that we might take with that, just to reduce the complexity. Yeah, that's yeah. But one more thing is that a lot of like the members, I guess, that were in the object detection group, like they were interested in the kind of the classification part of it. So mainly going on interest as well. And the fact that there are a lot of data sets out there like for this, because it has been done like numerous times. But again, I guess every case is different. But I think it definitely would be worth a try. But I think as like a fallback option, something like, sorry, I didn't catch your name. Jehan?
Yeah, Jehan.
Jehan, okay. As Jehan said, and use that approach if that fails. So that's kind of the part of, I guess, the timeline, kind of making things a little shorter. So fail fast, and if things end up not like working out, you can switch gears into something that is a little bit less complex, or switch to checkers or something like that.
Okay, I think that may be it on questions, and also just going off of the time, I think it's time to switch to the next project. So we can do, yeah, does anyone have any last minute questions? Okay, I'm going to start pulling up the Rocket League slides. Okay, is everyone able to see that? Okay, I see some nods. Okay, so this is the Rocket League project, and this is where we're getting our name from. We're still not entirely sure if it's completely legal to just use the word Rocket League like this, or if that's some sort of trademark infringement. So we should look into that at some point. But some of you may be familiar with the video game, and this is where the inspiration comes from. Basically, it's soccer with high performance cars. So the game unapologetically does not try to be realistic to any sort of physics that exists on Earth. So that's sort of one of the, and as part of that, the game is able to be a lot more exciting because they aren't sort of bound by that. And we're trying to recreate that excitement using physical RC cars and some sort of ball inside a field where we're going to have autonomous agents basically playing robot soccer. And we're going to try to keep some of the excitement from the game, even though some of that, of course, is going to be lost whenever we have real world physics applying to it. And then some of the key features for what we're trying to capture are the interaction between different autonomous agents. So typically the game is played 3v3. So there's some sort of teamwork aspect going on where these three cars need to be able to communicate to one another and play the game. Because normally it's 3 humans against 3 humans, and you can use your microphone or whatever to talk to the other person. So sort of a long-term goal might be to see what can we do with or without a hive mind to capture that teamwork ability. And then there's also a competitive aspect because you're going up against other cars and you have to sort of predict what they're going to do and learn from their behavior. And so those are all sort of, far off goals for the project. But it was one of the things that interested us to begin this. As far as the current status of the project, this is a picture from what we had last semester. So you can see everything's labeled there pretty nicely. So we had a small scale RC car and a little soccer ball, and then we're shooting it into the cardboard goal. We used April tags, as Daniel mentioned earlier, and that lets us track the location of everything without needing to put sensors on the individual car or ball, just because due to cost and size and weight mainly, we want to have everything off board. So you can see the camera at the top of the screen is fully external, as is the processing. As of last semester, everything starts statically, and then the car has some ability to plan a trajectory so that the ball will go into the goal and then execute it. There are still some issues that we need to work out, but that's sort of the baseline that we're starting with. Our planned deliverable for this semester is to simplify the 3v3 so that it's just 1v1, 2 autonomous cars facing one another. And then additionally, we have the option to control one of the cars manually. And then we're planning to do some testing between the 4 different autonomous agents that we're planning on building, the 4 different policies to control it, versus a human. So that gives us a lot of different combinations of ways that we can match those up. And we're looking to sort of do a research experiment just to see, how those perform relative to one another. And then the last part of the deliverable is just to publish our results. And we're looking at a YouTube video as well as making a blog post on our website, PurdueARC.com. The deliverable, before we go into the schedule, it's probably best just to quickly talk about how the system architecture works. And we have the same color coding between this and the timeline to make things a little easier. But everything, this is sort of how information flows between the system. We have software in orange. So you can see we have a high-level planner, and that's the main emphasis for this semester is going to be developing that. And then we have what we call the mid-level planner is in the dotted line. That creates a trajectory, and then it controls the car to follow those waypoints. And then we may or may not remove that depending on what our high-level planner looks like. We could use what's called an end-to-end model. And then everything inside the double lines is sort of like the physical aspect of the game. And that can be replaced with a simulator that we have developed, and we'll be using that simulator for testing and for training the neural networks. And then in there, so we have a low-level controller, and so that's controlling the car, sends commands to it through an interface, and then the car is going to interact with everything. The sensors pick that up, that goes into our localization system, and that spits out the location of everything in 3-dimensional space, and then that feeds back into the system. And again, just to note, everything here is developed from last semester except for the high-level planner. Like I think each part of this we're going to touch in some aspect to improve it, but we're not starting from scratch with any of it except the high-level planner. Okay, here's our timeline. So it has the same color coding, hardware, localization, and software. And then I'm not going to talk about all of it, but I'm really just going to talk about the testing here. So I have our critical decision points marked out. So just recently we determined the field dimensions. It's going to be 15 feet by 10 feet. And then we've got another point where we're determining how the requirements of one system impact another. And so that just sort of shows where one entity impacts another, and it's important to have the whole group come together to make a decision. And we're hoping that by putting that in the schedule, it can keep us on track and reduce one team waiting on what another sub-team says. And then we've also got our integration testing along the bottom. So last semester, our integration testing purely consisted of just, I think, 2 or 3 weekends right at the end of the semester. So this time, I'm pretty excited that we have 2 of them planned out during the semester, as well as sort of a last-minute push. And for each one of those, we have marked out what specifically we're hoping to be able to test. And by doing that, it gives us sort of a hard deadline that we need to meet. Because we're going to plan these integration tests, and if the software isn't ready, that's fine. It just means that we won't be able to test it to its full capability. And I think that'll do a good job of forcing us to ignore feature creep. Like if we don't have time to get it done, then the extra features just don't happen. And hopefully that'll hold us accountable. I'm going to move on to the budget now. And we can go back to any of these slides during the questions. So we had a little bit of income from SOGA, basically free money. So we got $1,500, which is really exciting for this project. And then we've got our expenses below. So our main cost is on the 2 things that we received SOGA money for, which is buying these RC cars, because they're, once you include batteries and everything, well, I guess the batteries aren't too expensive, but they're about $130 each. And we may make some upgrades to them from improving the stock components. And so those add up to quite a lot of money. And then the other major cost is in these cameras, because right now the club has 2 cameras, but since we're going to have a very large field, we think we're going to need 4 ultimately to be able to cover every part of it. So we have money to buy more of them. And then we've got a smaller amount of money set aside for miscellaneous building materials and some electronics. So this is all I have prepared, so we can ask some questions now. Anybody can ask a question if they want. The silence is deafening.
So were the biggest changes from like last semester, like the integration tests in terms of like process?
Yeah, in terms of our process, the biggest change here, I'm going to try to go back to the slide. The biggest change is just having those 2 integration tests happening before, and having clearly marked out what we want to be able to test at those meetings. I'm hoping that'll keep us honest.
What simulation are you guys using?
Harrison, do you want to talk about that?
Yeah, we'll be essentially revamping a little bit of the sim we built last semester. So that's just a sim that runs completely in Python. It's using the Box 2D library, which was originally developed in C++. But we made an adaptation of it so that it's wrapped in a ROS node. And then we have scripts that run and simulate the field. We just need to ensure we're improving it so that it's robust enough to handle testing and training the data set.
Cool.
And to reiterate, the sim does everything inside those double lines.
So something like that, I guess looked into was ROS plugins. I don't know. Have you guys looked into those or like, you know, using those at all?
I think I've heard of them, but I don't really know what they are. Can you tell me more about them?
So it basically allows you to create like multiple like different implementations of like, let's say like it's kind of like an interface, I guess, where you can implement like multiple different types. And like, for example, the kinematics libraries in Move It are all ROS plugins. So you can implement different controllers and different or different like inverse kinematics libraries and stuff. You just have to create one like base like plugin, and then you can just like, you know, kind of like a interface in like Java kind of thing. So like if you guys have, I guess, different like trajectory planners or controllers or planners you guys want to maybe like test out, or like have others, like maybe if you want to like, you know, if you guys put it like open source something, like that could be something you could like convert it into.
Yeah, I think modularity is definitely something we've been discussing, especially since we have the plan of doing parallel development of multiple different sort of implementations for the high-level planner. And that's definitely something in consideration. It's already sort of written so that the Python class that we get the sim from and get the data from is pretty configurable and can change pretty easily on an instance to instance basis. But ROS plugins might be something to look into just to make it more of a seamless integration with the overall ROS system.
I have a question about the simulator. So some of the training data for like the high level planners we're using might be image based. I don't think the simulator would be able to accommodate that, would it?
Yeah, probably not to the extent we would need. I'm sure there's something we can look into. I wasn't under the exact impression that a lot of the training would be image based, especially since how we receive currently in the system, the data is already in a format where it's been sort of processed to get back like the poses and velocities and the general motion of all the field elements.
Yeah, I don't think we have any capability really to produce high quality graphics that could be used for training a CNN.
So maybe this meeting is the wrong, but I just thought of this today because I was working on something else. And so if we're using something like an end-to-end learner, right? Rather than feeding it pre-processed information about the position of the ball and the goal, for example, we'd want it to discover that for itself. So that's things like training something like that would sort of require like an image-based or pseudo-realistic type of simulator. I know there's something called Airsim, which like you can develop environments for that in Unreal Engine. Is that something we could consider somewhere down the line for a simulator?
That might
Yeah, I
be.
think.
Sorry, Harrison, you go
Very-
first.
Yeah, I was just gonna say that might definitely be an option, especially since a lot of the simulators that I know are especially big in the self-driving industry probably represent the physics a lot better than we're doing within the Python simulator. Another option could just be to, if it's dumb enough, overlay the like asset images of what's on the field from a top-down perspective and see if they get results. But yeah, I think that definitely might be something to consider, especially if it's going to sort of just do a lot of the work for us and not have to force us to reinvent the wheel with the Python implementation.
Yeah, I mean, my perspective, I guess, is since one of my personal goals for this project is to kind of thin everything down as much as possible. I guess my immediate response is that it seems like it might be a little bit too much overhead. But I think Harrison makes a good point that it may actually end up saving us time if a lot of this stuff is already implemented for us. But yeah, the one note I want to make is that we do have a very robust, or at least it's a somewhat robust localization system that we're planning to make very robust. So we were just talking about reinventing the wheel, and this may not be the right meeting to talk about it. But it seems like it would be nice to use that localization data if we already have it.
Cool.
Okay, I think it's been 15 minutes now, so I think and there aren't any more questions, so I think we can move on to the next project. I think you're muted.
All right. Hey guys, my name is Lena and I'm the project manager for the Wizards Chess project. And right now it's mostly just like we're just getting things started. We don't really have anything yet. But it came from the inspiration of like this scene from Harry Potter where like the chess pieces are larger than normal and they can move on their own. Obviously, we don't want to make chess pieces this big, but something that's like bigger than normal is good. So for our project, we're gonna have to make 32 robots because like we have 32 chess pieces and each one of them should be about 1 foot by 1 foot, but that size is really going to depend on our budget, and the budget has to depend on the size because we don't want to be spending like too much money. And each chess piece should be able to move diagonal, front, back, right, left, so that you can have like the queen movement and like bishops, rooks, pawns, all of that. And then each piece should be able to know exactly where it is, and then accept voice input, and then determine the pathing to each place and get there without collisions. So, and then we don't really have a timeline because the timeline is mostly dependent on the skill level of like this people involved in the software side of this project. But in terms of hardware, I want to be able to create like the chess pieces and the field fairly quickly so that we can get to like integration of software and hardware. And then for the budget, that also depends on how big we want the pieces, and I would love to talk about that with like our team once we get together for like the first time. So that was just like a quick summary. If you have any questions.
What level of coordination are you looking to do between the pieces? Are they going to be taught, or I guess between the different? These are planning on being like mobile robots, right, for each individual piece? Okay, yeah.
Yes.
So yeah, what level of coordination do you expect to be happening? I know you mentioned at some point they need to be able to respond to voice commands. Are they all just going to be listening in and telling themselves, if I hear my name, I'm going to move? Or is there going to be some like inner communication happening between the different pieces on the field?
I think it's more like each one should have awareness of like what's going on around it, and like if it hears their name and the spot on the field, like knight to e5, then it should be able to path a direct, like plan a path to that spot on the field and like know where it is and have awareness of the chess pieces around it so it doesn't collide into them.
Yeah. Knights seem like they'd be the hardest to move though, because they can have pieces in the way and still get somewhere.
Yeah, definitely. So I've thought about that, and like if we make like the pieces small enough compared to the size of the squares, the knight can easily move between the pieces and be able to reach its destination.
This
makes sense.
just brought back a deep memory from childhood, but I used to have this. I like for Christmas one year or something. I got this chess set that had pieces that moved itself, like with magnets or something. And like the way it worked was it like moved the pieces out of the way. To
Yeah, we could also make it so that the pieces move out of the way and remember their position. So once the knight moves, like they'll move back. But I think that's a lot harder
yeah,
than
that
just.
also like
Sorry.
yeah, sorry. I would require a lot higher level of coordination between pieces.
Yeah, it really would. Yeah, and then we also have to, one thing that I haven't thought as much about is figuring out how to get the pieces, like how to tell when the pieces have been like captured and like get them off the board. That's something that we need to think about.
Well, in the movie, they annihilated each other. So I
Yeah.
hope you're not planning on doing that to your robots.
I
'cause that
really
would
don't want to
pain me in
destroy
my
the
soul.
robots. Yeah.
Okay, that's good.
A less
Um,
violent way of getting rid of the pieces.
Yeah.
I think one thing that you could do for that is just to have like a running kind of data set with what pieces are where. And then if the other player moves their piece to that place, then if there's a piece already there, that one would have to move off before the next one can move to that spot.
And
Yeah.
already, if they're listening, like you'd say, you know, knight takes b5 or whatever. So then the piece on b5 can listen and say, oh, I'm dying.
Oh, that's true. Yeah. That could also.
Also, like another question that I wanted to ask is like, how are you gonna make sure that like all the pieces don't listen to the same advice?
So are you talking about like if
Like,
like there are different pawns and you say like pawn to
yeah,
so there are a couple things we could do. One of them could be is like each pawn can have a unique identifier, so like pawn 1, pawn 2.
Okay.
That would get confusing quickly, but it is an option. Another thing would be like if you say pawn to b5 or something,
the
it'll
closest one.
They'd all check
Yeah,
and see if it's legal.
yeah, let's see if it's legal and then it'll move there.
Alright.
The only problem is if there's already a piece on b5 and there are 2 pawns that can move there, how will it decide?
But if 2 pawns
yeah.
can move, like already you'd specify like pawn on e to b5 or whatever.
Yeah, you could also use like the square identifier, so like pawn on b3 to pawn to b4.
Yeah, I mean, this is definitely already a solved problem. Like if you look up PGN for chess, it describes like sort of how you're supposed to identify what pieces you're looking to move in a way that can always just the board is always able to make distinguishing arguments about which piece is supposed to move in which instance.
Yeah, I've done a couple chess tournaments and they always like we have to record what we're doing and there's like specific notation to do that.
Yeah.
What sort of like higher level organization are you planning between the pieces? Like, is there going to be some sort of like central unit for each team, like where you say something and then it sends a signal to the specific piece, or is each piece listening independently and then figures out how to execute it?
I think it would be interesting to do it so that each piece is listening and then it'll figure out which one that, but it might also make more sense to do it so that like you're directly talking to one piece. If you're directly talking to one piece, then you don't really have the problem of like mixing up between pawns and like different pieces. But that's something that we definitely have to think about. And I think it also depends on the skill level of like the software developers that we'll have.
Yeah, I think I agree with you that it could be like more simple to have a central unit, but it could definitely be like a cooler problem to solve, and you know, making something a little bit more difficult for yourself if it's going to be something that you're more interested in solving. I don't think that's always a problem.
Yeah, like I would love to have it so that like you just say it and then it just moves. So
Yeah, software wise, it seems like probably the voice recognition is going to be the hardest, but
yeah, definitely. But I think in terms of hardware, we just really need to design and then build. I don't think there's much.
Also, another question is like, do you think like the pieces will be able to like recognize like somebody's with an accent or something?
I hope it will be, but that will be hard to do. But that
Alright.
should be something that we need to solve and figure out.
Do you know how the pieces like would like look like? Are you gonna have like, let's say, like something like 3D printed on top of the kind of all the like electronics or something like that? Or actually 3D printed, I don't know how you're going 1 feet by 1 feet, I don't know. But are you trying to like overlay it with like the piece or something?
I think at least for like the base, we'll have like an X drive so that I can move all the ways, and then on top of it, it should have some identifier of like what piece it is, but how big that is would also depend on our budget, because like 3D printing costs money.
Sounds good.
If they're really big, I don't know if 3D printing is the best way to go. Well,
Yeah,
yeah.
we could use cardboard cutouts or something.
Yeah, or like modeling it
You
out. with
could
styrofoam.
CNC.
Yeah.
For as far as timeline, and I know you're still working on this and getting the team together to work things out, but are you planning on taking an approach where you sort of work small and then sort of over time develop yourself to have a system that's a lot larger, or sort of fail faster, build the bigger approach, see what goes wrong and fix it from there?
I think we're gonna start by like building one robot and like making sure that that robot can respond to voice commands and like move the correct way. And then once you have like one robot with the software needed, we can just, I guess, mass produce it to all 36 pieces.
With that one robot, are you looking at doing it at scale or on like on
Um,
first iteration?
Perhaps.
I know time is running out, but like one quick question. So you said that you're gonna have mainly the one robot, each robot individually take commands, and so like how are you guys or how are y'all going to like have the pieces like communicate with each other? Is that going to be like is everything connected to like some like master kind of thing? I think James. I don't know if James asked this same thing, but
The pieces, like, they should, I think in some level they should like know where each other are and like which one's being talked to. But if we want to make it easier, we could also have like a computer program running so that like once a piece or like you talk into the computer program and then the piece will move there and then the board will reflect it if we want like a more centralized like control center, I guess.
okay. Because like the only thing was just like you'd have to have more sensors and stuff on each
Yeah.
camera or something. But yeah.
So this is a similar question to what I had for Raghava's project actually, but are you planning on having like two people playing chess through the board or one person against a chess engine? Or maybe that doesn't matter right now?
At the beginning, I think two people playing chess is like what I want, but maybe later we can also implement like AI so that it's human versus AI and the chess pieces will move on their own. And then you could just play like that.
Okay. Yeah, because one kind of fun idea I just had was what if you don't play against a single chess engine, but somehow each piece is somehow trying to decide what the next best move is, and somehow they all have to make a decision on what that is without having some sort of central decision-making unit. I think that could be a really interesting area to look at, but it may also be different from what you're planning on, so that's fine.
Swarm.
No, I think that would be interesting, but I think that's later on.
James, I actually have a logistical question.
Yeah.
There are 4 on the sign up sheet for the Bechtel Center swipe access. There are 4 people for Rocket League that are not you that have swipe access, and I was wondering if Rocket League or Wizard Chess was planning on using the Bechtel Center, because there are 4 people on Robot Arm who are interested in hardware who would like access.
Okay. Yeah. Did you? Yeah, we might want to talk about this offline, actually, just so we're not taking everybody's time here. But we can
Okay.
figure that out after the meeting tonight. So just stay on Zoom. And anyone who's
All
interested
right, I will.
in hardware access at Bechtel.
For those of you who forgot, Dio, Michael, Owen, and Arian were the ones who should stay behind.
And then another quick note, I just made a Wizard Chess channel in Slack. I'll put a link to it in general.
Thank you.
But definitely join that because, well, I just invited you, but anyone who's interested in the project, join that so that we can figure out exactly who's on it and everything. Okay, I think this probably wraps up the meeting for the most part. I've got one slide left just talking about next week's meeting that I can share really quickly. So next meeting, we're planning on doing a walkthrough on the Snake tutorial. So that's sort of a tutorial on how to use ROS, Docker, everything else that we use with the club. We're using Python too. So highly recommend that if you're interested in software at all for robotics. Lots of good skills that you'll see in industry. As far as what you should have going into it, whenever you actually look at the guide to get started, it has a mention about going into a docs folder and installing all of the software prerequisites. So if you have all of those done beforehand, then you can follow along during the meeting. Of course, you can also just watch during the meeting and set up your stuff afterwards if you want, or you can do the tutorial beforehand and just watch the, follow the written tutorial beforehand and then watch the video tutorial during the meeting just for more information. So it's up to you on how you consume that information, and we'll post it on YouTube afterwards as well. But yeah, just a note about what we're doing next meeting. And then after, sorry, did someone say something?
Yeah, I want to ask a question. So, what if, for example, I completely mess up the written tutorial and I want to restart on like the video one? Like, is there a way so like I can like delete everything from my computer so it won't like be a mess?
Yeah, so if you want to, we're on the video tutorial, we're not going to go through the software setup. So I don't know which part of it, if you're talking about the software part of it is where you're like halfway through that, or the tutorial part of it you're halfway through.
Actually, I'm like kind of like beginning to like set everything up, but I just want to know like in case like I mess everything up, like if I can have any help to like do it.
Yeah, it's a pretty simple command, and I guess at the start of the video we can talk about how to do that then, just so everybody can be starting at the same page.
All right, sweet.
Okay, any other questions on the tutorial series next meeting?
So should we like install WSL2 and all of that and get all of that set up before the meeting?
Yeah, so that's whenever I say software prerequisites, I mean, if you're on Windows, install WSL2, and then no matter what platform you're on, install Docker. And then if you can even build the base image and just have that ready to go, that'll be a good starting point. If I have time, I might produce like a short video beforehand, just like showing you what I mean by that. And I'll just have like a simple test where if you can run this, it means that you're ready to go for the meeting.
Okay.
Essentially, it's just everything in the docs folder within that drive or within the repository.
Just a question. So all the information, all the information to set up the software is in the GitHub repository.
Yep.
Okay, cool. All right, thank you.
And maybe we should post a reminder just with the specific folder where all
Yeah,
that.
could you just like, I don't know, resend that link or whatever it is?
Yeah, I'll grab that real
And
quick.
thanks a lot.
Okay, and then after, I think we're done with questions about software. Okay, so after that meeting, I think these general meetings are going to start becoming bi-weekly, just because we won't have that much to talk about. So I guess you guys can look forwards to having an extra hour back every Wednesday night. Okay, so I think that concludes everything for this meeting. So stay on the line if you have, so Sarah and everyone she mentioned about talking about Bechdel access, stay on the line for that, or if you have any other questions. But otherwise, I guess this is the conclusion for the meeting. See you all next week.